Welcome. So, we were doing this trying to find out the resultant field when time is such that omega t equal to 30 degree. All angles are electrical, okay, fine. So, I found out the R phase field, Y phase field is not there. So, axis of B is this 120 degree apart and it is carrying negative current, therefore, the field will be like this. So, the resultant field will then lie here and obviously, the B resultant at omega t is equal to 30 degree will be just 2 times root 3 by 2 B max and cos 30 degree. We know two equal forces P, angle between them is alpha, resultant is 2 P cosine alpha by 2, something like that, whichever way you do. Okay. Or you can 30 degree its component here, vertical components will cancel off. So, 2 P and this cos 30 degree. So, this one is 2 cancels. So, root 3 B max into cos 30 degree is once again root 3 by 2 is equal to 3 by 2 B max. So, what is the observation? Observation is these coils are carrying balanced 3 phase current at omega t equal to 0. I noted my time. The resultant field was horizontal and its strength was 3 by 2 B max. Time passes, omega t becomes 30 degree and the resultant field then moves from this. So, originally it was here at omega t equal to 0 it was there. Time passes, what is the resultant field? 3 by 2 B max. Time passes by 30 degree, resultant field strength remains same 3 by 2 B max and it moves 30 degree in this direction, in the clockwise direction, and it is consistent with this result because we found that 3 by 2 B max cosine omega t plus theta is the equation of this, which told me that your resultant field is moving in the negative direction of theta. Positive direction of theta I am measuring, this is theta equal to 0 this way. So, it has indeed moved in the negative direction with keeping its amplitude same and coming here. One can go on doing like this. Okay, take another instant omega t equal to 60 degree, you will find that okay, resultant field strength will once again remains 3 by 2 B max and it was initially here at omega t equal to 30 degree, it came here, the length is same. At omega t equal to 60 degree, you will see it has gone by 60 degree, strength remaining same. So, it looks like that as if a sine wave of amplitude 3 by 2 B max is moving in the clockwise direction of this in space. What is the speed? Speed is same as omega, because whatever is the omega t equal to 30 degree, by that time it has gone by 60 degree. Therefore, speed is omega, omega electrical radian per second. You must understand it. About speed we will talk at great length after some time, but this is the thing. Now, the question is okay, is it that we have to go on proving for various time for all the time. Is it true? Yes, it is true. Another nice way of showing that is this. See, go to the same diagram. This is your R phase, this is Y phase and this is B phase. So, this is R 1, this is Y 1, Y 2 and this is B 1, B 2. When current enters through one terminal, field is away from the center, that is the direction of the field we have chosen, and this is my reference of theta is equal to 0 and theta I will measure positive in this direction, theta positive. Okay. This was the thing. Now, I know at omega t equal to 0, I will do for that case. Omega t equal to 0, I found the field was here and it was 3 by 2 B max at omega t equal to 0, B resultant. Now, suppose I will now say, okay, instead of taking some discrete values of angles, let us say that if this is omega t equal to 0, then you say at any time omega t, at any time omega t, time passes any time, any arbitrary time omega t. In that case, this is the current I r is equal to I max sin omega t, is not? This is the current in R phase. What will be the field produced by this? This will be just this. In this direction only, and the strength of the field is B max, because I max is there, B max into sin omega t. This will be the strength of the field along this line. Okay, at some omega t it may become negative. So, negative vector of this. So, equation will take care of this oscillation, whether it is correctly this way or that way. So, that sin omega t terms will take care of that. Any arbitrary time t, this is absolutely correct. If this is I r, your field will be this, because I r direction I have shown I max sin omega t. So, I max produces field. So, strength of the field is now a function of the time. I have drawn a vector, okay, at any time t, this is the vector. Sin omega t or cos omega t? Cos. I must write cos, because cos is so nice a function. So, B max cosine omega t, this will be the field. What will be the field produced by the Y phase current at any time t omega? It will be 120 degree apart, and this will be B max cosine omega t minus 120 degree, because at time omega t R phase current is cosine omega t, Y phase current is cosine omega t minus 120. So, this lengths may differ. I do not, because this is cosine omega t, this is cosine omega t minus 120. They are not of equal lengths or half or root 3 by 2, I do not know, but arbitrarily depending upon that instant I should adjust this length. On the top of it, this current may be negative instantaneous value. Then this equation will give you a negative quantity, which means actually your B is opposite. So, equation takes care of that reversal of the vectors. So, it is a sort of generalized approach, but nonetheless this angle is 120 degree electrical. Similarly, B phase will be maybe like this, I do not know, omega t, and it will be B max cosine omega t plus 120 degree, is not. This will be the B phase, this is Y phase, and I want to add these 3 vectors up. So, at any instant omega t, of course, that once you fix up omega t, this is a constant length, that is what we did earlier, by a constant length this that we found. Now, to find out the resultant of these 3 space vectors, what we do, let us say how to find out this resultant of these 3. Let us assign this is my x axis, let us say, and let us say this is my y axis. Okay. Then what I will do? I will find out the x components of these 3 summed up, and also sum up the y component of these 3, then the resultant field vector x component will be sigma x component of component vectors and sigma y components of the component vectors, that is the idea. So, let us calculate B resultant x component. What it will be? It will be, you can see, B max cosine omega t. This calculation you watch out carefully. So, B max cosine omega t is positive x, it is there. Then there are x component for this and for this vector, which are in the negative direction. So, it must be then minus B max cosine omega t minus 120 degree, this one, but this angle is 60 degree, this angle remains 60 degree, this into cosine 60 is not negative of that, because it is in the, we can easily see. Similarly, this component minus B max cosine omega t plus 120 degree into cosine 60, and this must be the resultant field x component, because the constituent vectors of B resultants are this. So, this is the thing. Now, cos 60 degree is half. So, what I can write it is this B max cosine omega t, that is there, and this is minus B max cosine 60 is half this, and this is cosine omega t minus 120 degree plus cosine omega t plus 120 degree, is not this. And this I can simplify in an intelligent way, is this, that this is B max by 2 and this one must be minus cosine omega t, because sum of cosine omega t plus cosine omega t minus 120 plus cosine omega t plus 120 is 0, that result is known. So, sum of these two is nothing but negative of this, and which simply becomes 3 by 2 B max cosine omega t. So, mind you, this is what? This is the B resultant x component. Okay. Similarly, I find out the B resultant y component. Let me do it here with different colors. So, B up to this B resultant y component will be for all the component vectors, take the projection on the y axis. So, for B max it cannot be, for R phase no projection. So, only for this and this. So, it will be, so far as this one is concerned, it will be B max cosine omega t plus 120 degree, and then this angle is 30 degree, because this is 60. So, 30 into cosine 30, and for this it should be negative, minus, because its projection here is negative. So, minus B max cosine omega t minus 120 degree, and once again this angle is 30, cosine of 30, and this, if you cosine 30 is root 3 by 2. So, it is root 3 by 2 B max, and you will be left with cosine omega t plus 120 minus cosine, is it correct now, omega t minus 120. Hopefully, no mistake anywhere, resultant of this one. So, this will be the thing, and B resultant y, it will be root 3 by 2 B max. This one you take this negative sign common, and you will be having cos A minus B minus cos A plus B, which means 2 sin A sin B. So, sin 120 degree is how much? Sin 60 degree. So, 2 sin A and sin 120 degree is, so sin of 120 degree. So, sin 120 degree is here, which is 60 degree plus all sin. So, sin 60 is root 3 by 2. So, into sin 60 root 3 by 2. So, this will then become minus, this 2 goes, and it will be 3 by 2 B max sin omega t. So, this is B resultant y. So, what we have done? We have calculated for any instant, suppose this was my omega t equal to 0 instant. From that, and at that time I knew the resultant field was horizontal, I knew that. Then I am telling that let any time passes, time becomes omega t, from omega t equal to 0, then where is the resultant field and what will be its magnitude, I want to calculate. So, I get at omega t, any omega t, I find out the phasors, this length need not be same. Then I find out this 3 I want to sum, where there is a time varying term, but nothing wrong in that, length at any time t, okay, this is suppose the length, and then I want to add this 3. So, while adding, what I have done, I have calculated the x components of each of the components, added them up, and I can tell that must be the x component of the resultant B vector. Similarly, the y components we have calculated. So, separately. So, B resultant x. So, finally, what we have got is this B resultant x component is equal to 3 by 2 B max cos omega t, and B resultant y component I have calculated this one, which is minus 3 by 2 B max sin omega t. This is the thing. So, what will be then the B resultant? B resultant magnitude? It will be under root B resultant x squared plus B resultant y square, and that is nothing but 3 by 2 B max, is it? And where will be its position? My x axis was like this, my y axis was like that, x y axis, and this was my B resultant x, B resultant x, and this was my B resultant y, and the resultant is this. So, what is this angle? Resultant with B resultant x is this by this tan inverse of that. So, the angle will be this theta, if I call this is theta, tan theta is nothing but this magnitude, that is tan omega t, that is all, is not. So, this angle is this magnitude divided by this magnitude, which is omega t. Therefore, we see as time, any arbitrary time is gone, then the resultant field at omega t is equal to was there of my amplitude 3 by 2 B max. Time passes by omega t, that also moves by an angle omega t in the anticlockwise direction. I mean, same thing we looked at from different angles. Therefore, the conclusion of this lecture is this, that when a balanced 3 phase winding, you must be clear about your theta equal to 0 and positive theta. If this way you have connected and passed current IR, IY, IB of phase sequence RYB, you will see that eventually what happens is this I am drawing by some sketch, I will do it like this. A resultant magnetic field of amplitude 3 by 2 B max, and its speed of rotation is omega, because this clearly shows this angle is omega, sin omega t by cos omega t. So, time passes omega t, it moves by same omega. Therefore, with a speed omega, electrical radian per second, it moves in this way. Okay. Some people say in language, they say the resultant field will move from leading phase current to lagging phase current. I mean, forget about all mathematics, it boils down to if R phase is carrying with respect to Y phase leading. So, from leading to lagging phase it moves. Strength is 3 by 2 B max. What is B max? Each phase produces its own pulsating magnetic field, the amplitude of that B max, which corresponds to I max. So, this is the phase magnitude. Okay. B max is each the maximum B flux density produced by each phase, and that will be same for all the phases, because same I max is flowing. After we have done this, I will ask you a simple question. Suppose I have a winding like this. It is your R1, this is Y1 and this is B1. Now, if this 3 coils is energized once again by balanced 3 phase currents, but with the supply phase sequence reversed, that is you connect R to R phase, the supply R to R phase, supply Y to B phase and supply B to this Y axis. These are supply names. Then what happens is this, the IR, if you call it I max cos omega t, I y will be leading, phase sequence is reversed, supply phase sequence. It will be I max cosine omega t plus 120 degree and I b is equal to I max cosine omega t minus 120 degree. You will find once again a rotating magnetic field is produced, but it will move from, it will be doing this, a resultant field will be produced, but this time it will be moving like this, because R phase is the leading, leading to lagging, it moves R, Y, B, whichever phase carries lag current. So, I R is this, I Y carries a leading current and this is Y. So, this is I B, I B is, let me write, this is I R, I B is lagging. So, from R to B it will move, whoever is lagging, I R, I B is the next lagging. So, it will move like this in the anticlockwise direction. Therefore, a rotating magnetic field of constant magnitude will be produced by a balanced 3 phase coils which carry balanced 3 phase currents, and the amplitude of the field is constant and the speed is also constant, omega, that is the electrical speed, electrical radian per second. So, this actually was first suggested by Nikola Tesla. Before that it was all DC supply and people were doing this, that. Then he told that if you can see, the example is, anyway in the next class I will tell that important thing, but the point is, if a balanced 3 phase winding, the coils are stationary, that is the most important thing, and you have been able to produce a rotating magnetic field without mechanically rotating anything. Okay. And the magnitude of this field is constant at all time, not at omega t equal to 0 or 30 degree. In discrete times we have shown that it is no matter what is the value of omega t, this field strength will be always moving. Okay, we will continue. अच्छा 5 मिनट देखिए.